So in the last session, we have completed till AHB protocol, right? So in AHB protocol, we completed the entire specification. What are the features of AHB and what are the signals available in AHB protocol, like um, different signals and the features like bus transfers. In bus transfers, what are the single transfer, increment and wrap, and what is the difference between split and retry response. All these things are completed, right? Even we just gone through the RTL design for all the like entire functionality of bus transfers, and also completed the verification in UVM. Okay, so I think you don't have any doubts in AHB protocol. So today we are going to start with the AXI. Okay, so what is mean by AXI? What do you know about AXI?
What is a
AXI is a high-speed bus protocol. It is used and I mean, as compared to APB and AHB, it is like one to many. It can connect to many IPs. It can connect to many. It can. It is a parallel. It is a mode of parallel transmission. So yeah, it is a brief of that. It has a separate channels for read and write. It has a 5 channels. So yeah, it's a brief of that. Yeah.
Any other answers? Okay, so AXI means advanced extensible interface. Okay, so AXI is a part of AMBA 3 and 4 specification. At starting day we discussed, right? What is meant by AMBA 2, AMBA 3, AMBA 4. So AXI comes under AMBA 3 and 4 family. So it is developed by ARM, and mostly AXI protocol is a high performance. For high performance and high frequency system designs, we use the AXI protocol. Okay, and mostly AXI we use in the SOC, system on chip designs. Okay, for high speed data communication between the IP blocks, we use AXI protocol, which is on chip communication protocol or bus protocol. Okay, so what are the major features of AXI protocol compared to the AHP? So what are the main advantages of AXI over AHP means? First of all, we'll look into the features. Okay, so first thing main is AXI protocol have independent channels. Okay, so if you see here, AXI have total 5 independent channels. Okay, in APB protocol and AHB, we don't have the channels, just signals are there. In APB, there is a write signal where we can do write, read, transfer. Cannot, both cannot be done at a time, but if write is high, write operation. If write is low, read operation. Like that, p address, p data, p slave error, p protect signal, and p clock, p reset. Like that, we have different signals. Even in AHP also same. H response, H write, H read signal, H address signal, data signal. There are different types. Okay, H master lock, H burst, H size, okay, H trans. Compared to APB, there are more signals for AHP. Okay, but what are the limitations we are facing with the AHP protocol? So write and read cannot be done at a time. Pipeline is not possible in AHP protocol. Okay, both write and read cannot be done at a time. It's not a full duplex communication. Okay, and also address and data should be wait each other. Okay, and multiple transactions we cannot do at a time. We cannot send the multiple transactions at a time. Okay, need to wait one transaction until complete, then second transaction can initiate, and then third transaction one by one. We cannot transfer all multiple transaction at a time. Okay, so first main feature of AXI protocol is independent channels. Total 5 channels will be there. A read side, a write side. Okay, a read address channel. First one is a read address channel. We call it as a AR. Okay, however, we represent the APB signals as a P address, P data, P clock, P reset, P stroke, P protect, like that with P. Same AHB, H address, H clock, H reset, H burst, H master lock, like that. For AXI, we have 5 channels. For each 5 channels, there will be separate signals. Okay, read address channel means read address, AR address, AR data, AR clock, AR reset, like that. Each have its own signals. Like that read data channel. Second one is a read data channel, or it represent with or. It have its own signals. And write address channel, AW. It have its own signals. Write data channel, write response channel. Like that 5 channels. This is first main interview question. If you are a fresher, you will get this question definitely. Okay, what are the 5 different channels? Read address channel, read data channel, write address channel, write data channel, write response channel. Address or data, both for read and write, it will be available. For response, only write, because read side it just give the response to the write, right? So only write response. Okay, and also it will allow the pipeline communication, which is a parallelism. Okay, so AXI protocol have the pipeline mechanism. Okay, and next thing is AHP protocol have the burst transactions. It supports the increment, fixed, wrap, burst, so that it reduces the address decoding and all. And also it have the separate read and write channels. Okay, as I told before, it have the independent channels, right? So write and read are separate. So what is the advantage? Both write and read can do at a time. But in AHBXI, if write is high, read is low. If read is high, write is low, like that. Okay, but in AXI, we have separate channels so that read and write can be independently executed. Okay, next next feature is like out of order transactions. Out of order transaction means transactions can be completed in any order with the help of ID. ID will be given to each transaction. Okay, based on the size, based on the speed, the transactions will be completed at any time. Okay, if someone is in lobby, please admit them. So out of order transaction, like that multiple outstanding address, as I told, we can transfer the multiple transactions at a time. And another thing is quality of service. It check the quality of service at every level. Okay, however, in VLSI design, we have the quality of service at every floor, every step, every level. That means once architecture is designed, micro architecture is designed, we check the quality of service. Once RTL program is ready, like Verilog HDL is ready, once the circuit netlist is generated, we check the quality of service. Like that, once verification is done, we check the QoS. Like that, logic synthesis. After logic synthesis, DFT. After DFT, physical design. In physical design, first floor plan, routing, placement, routing, clock tree analysis. Every flow, every level, we check the QoS, right? In the same way, for AXI protocol, we have QoS levels. Okay, and it have the transaction IDs. And another main thing is it support for unaligned data transfers. You already know AHB protocol is a aligned. Aligned means what? You already seen. Burst transfers are divided into the number of addresses based on the increments, based on two +2 increment or +4 increment based on the burst, like increment or wrap or 16-bit, 8-bit or 4-bit. Based on that, is aligned. The address is aligned, right? But in AXI protocol, it transfer the unaligned data transfers. Okay, so that we can access the memory easily, flexible. Okay. Next feature is handshake mechanism. Handshake mechanism means what? In AXI protocol, we have valid signal, valid and ready signals for every channel. Okay, so that uh, we just we get the synchronized communication. Okay, so based on these features, automatically it have high throughput and low latency. The delays will be less because obviously it is pipeline architecture, right? So high throughput means because it support the multiple out of order multiple outstanding transactions, and it allow the out of order transaction complete, and it enable the burst transfers up to 256 beats of burst transfers it will be enabling. Okay, so that's why these are the best features of AXI protocol. Is it clear, everyone?
Ma'am, low latency means
Hmm?
you said high throughput and low
Low
latency.
latency means what? Delays. Low latency means high speed. Low latency means low delay between the transactions. That means high speed. Latency means delay. Don't you know that? Hmm?
No, ma'am, forgot that.
Latency means a delay only. Okay. So next thing is what are the advantages of AXI over AHP? So obviously there will be lot of advantages in terms of speed, in terms of read write, in terms of burst transfers, in terms of out of order, in terms of pipeline, in terms of complexity. Complexity wise, AXI is very high compared to APP, AHP. Okay. Speed wise, AXI is very high compared to APP, AHP. APP is very low, AHP is medium. Okay. Pipeline, uh, AXI is fully pipeline. Multiple channels out there, right? Because of multiple channels, everything will run parallelly, so fully pipeline. AHP is, if we want the pipeline, then we have the limited features of pipeline. But APP, we don't have a pipeline architecture. Okay. And next, read write, you already know in AXI we have separate channels like this. In AHP and APP, we don't have the separate channels, shared read write. And burst transfers, you already know we have multiple burst transfers in AXI and no burst transfers in APP. And complexity wise, it is high. And how much width, transfer width for AXI means up to 1024 bits it will be transferring. Okay, but AHB is up to 128 only, and APB up to 32 bit. For joining, APB up to 32 bit only. Okay, so next, so this is what different advantages and difference between APP, AHB, and features also completed. Okay. So what are the major limitations of AHP? Can anyone answer from these advantages of AXI? What are the major limitations of AHP? You already know, right? And limitations of APP.
Hmm.
Write and read at same
It's
time.
dependent. Right and read is dependent.
Write and read is dependent. Okay. Next.
PHP.
Transaction also like they're defined only there in HTML.
Transaction.
Means that rates to be incremented by 4 or 8 like that.
Mhm.
They
Okay.
are in the same channel, read and write on the same channel, and it supports the only the aligned addresses and it doesn't support, I think, the out of order execution also.
Okay.
Can you explain again out of order?
Huh?
Out of order classics. Can you explain again?
How?
In XI feature, what is out of order classics?
Out of order trend. Yeah, we will discuss everything in next slides. Okay. Yeah, tell. Before that, just tell me what are the limitations of AHP and APP. Okay, AHP completed, right? Just no out of order transaction, low lack of QoS, quality of service. That means it cannot prioritize the critical data transfers, and also it doesn't have the read write channels, and also it have the shared bus, right? And So, what are the limitations of APP? Limitations of APP.
It's non-pipelined, low performance.
Non-pipelined, low performance. Okay. Next,
Low speed,
lowest speed. Okay.
no burst, and no handshaking.
Hmm. No handshake mechanism. Okay.
It
What is
doesn't
the
have the
difference?
burst
Bus transfers. Okay.
and lack of split retry option also.
For APB, we don't have the split and retry because when we
Yeah,
use the split and retry, whenever there are uh, multiple masters that time. But in
Mm,
APB, we don't have multi-master.
low
In APB,
bandwidth also.
low bandwidth. And also very cheap, like cost wise, it is cheap and circuit complexity also very less. Okay.
it is
So that is
just
all
used
about
in the microcontrollers only, right? Not processors. APP.
yes, just a small peripherals connection purpose we use APP. Okay, so that is what the difference between AHP, APP, and AXI. So coming to the AXI channels, if you observe here, we have 5 channels. Okay, write address, write data, write response, read address, read data. 5 channels. Okay, in each channel there are different signals. Okay, so the difference between transfer and transaction. Can you tell me what is the difference between transfer and transaction? What is the difference between transfer and transaction?
Transfer is a simplex like communication, like we can send to somewhere, while in transaction it is sending and receiving both parallelly.
Transaction means sending and receiving parallelly. Okay.
Like duplex communication.
Mm, okay. First of all, transfer means it's a single bit of data we send via clock. Okay, just a single bit of data, just one transfer. We call is just a transfer means one bit of data, some number of bits of data. That's what transfer. Transaction means the group of transfer is nothing but one transaction in that particular channel. Okay, so transaction is nothing but a complete operation which is requested by the master, and like we need to send entire fulfilled by the slave. Multiple transfers is nothing but a transaction. Okay, so write transaction, read transaction means what? Uh, write data plus address, address plus data. Okay, Write address plus write data is nothing but write transaction. Read address plus read data is nothing but read transactions. Okay. But transfer means just single bit of data, just a clock cycle, one clock cycle. For one clock cycle, we are transferring some data. That's what we call as a transfer. Okay, just for one clock cycle. But transaction means multiple clock cycles. Okay, clear? There are more this valid signal. I will explain once after each signal explanation. I will explain this so that you will get the clarity. Okay, so difference between, see here, difference between transfer and transactions. Transactions means all, multiple transfers is nothing but transaction. Transfer is nothing but single, just source to destination, one single clock cycle. Okay, so these are channel transfer examples. Okay, before that, let me explain the channels. Okay, so right channel. Right channel means there is a write address, write data, write response. See here, all the signals. How many signals are there in write address? These are the different signals. First of all, valid signal. So AW valid. Write address will be indicated with the AW. Okay. So AW valid means it's a single bit. So if you observe here, bits also indicated. AW is valid is a single bit, ready is a single bit, address is a 32 bit, size is a 3 bit, burst is a 2 bit, cache is a 4 bit, and protect is a 3 bit, and ID depends on number of transactions. And the length, AWN length 3 bit, 4 bit is there, 8 bit is there, and lock master. Just in AHP we have master lock, right? Same as here, AW lock 1 down to 0. Like quality of service and region user. Like this, we have these different signals. We don't use all. Okay, based on the specification only, we need to use. Mostly we use valid signal, ready signal, address, size, burst, protector, and ID also we use, and lock also we use. Okay, this length also sometimes we use, but QoS and region user are not mostly required. Okay, but we'll see what is the difference between each. Okay, so first one is AW valid. AW valid is nothing but master will assert, just it will indicate that the address signals and control signals are valid data, correct. Okay, correct data. Whatever the address is there, with the address, the data is getting correct. To indicate that, it just assert the valid. Assert means making high. Okay, so that is what valid signal. Whenever valid signal is high, we get to know that our data is correct. Whatever the transaction happened, the transaction is valid transaction. It's correct. Okay. Next, ready signal. Ready signal means what? Slave will assert. Slave assert is nothing but, if you assert means just low to high. Assert means just here. Slave will assert like this. Ready signal. If you see here, valid is asserted. Slave is asserted here. That's what assert means. Just making it as a high, low to high. Okay. So ready signal means slave assert whenever it's ready to accept the address signal and control signal, just like a wait state in APB protocol. You already know, right? Wait state, same as a wait state, ready signal. Okay. Next, address. Address means you already know, just 32-bit address. Next, size. Size is nothing but in AHP protocol we have seen, right? Size, just for each transfer we have 0000010. It just indicate the number of bytes, transfer of bytes. Okay, suppose if size is 000 means 1 byte transfer, 001 means 2 byte transfer, like that. 010 means 4 byte transfer, 010 010 means 8 byte transfer, like that, till 128 bytes of transfer. 111 means 128 byte transfer. Okay, So if you want to understand all these signals clearly, I will explain anyway. But for revision purpose, if you want to learn properly, yesterday I have shared you the specification, right? Just go through the specification. I already told you. So just refer that specification. So in this all signals you will get from chapter 1. AXA architecture is there. Write, see here, write and read request channel, write data channel, write response channel, read channel, what is meant by interface and what is meant by interconnect. Interconnect is nothing but where different masters and slaves are connecting here through a bus. That's what we call as interconnect. Interconnect is nothing but a bus, main bus. Interface is nothing but this from interconnect to just a signal is going to interface with the slave. That's what interface. Next, AXI transaction and transfer, just explain, right? What is the difference between transaction and transfer and signal list? These are the signals I am explaining now, all this. And these all are not required. Whatever the required signals, mainly whatever we use, I already just listed here. Okay. So if you, but still, if you want to just understand, just have a revision just one time. If you have some brief, if you read entire specification, you will get some idea. Okay. There are 285 pages, but still you need to read 285 pages. Okay. That's important. Then only you will get overall idea. Okay. But if you don't have the time to read the entire specification, at least whatever I'm discussing here, you can just concentrate on that. That will be enough. Okay. So next, what signal? H size is completed. Next, burst. Burst means you already know. We have fixed increment and wrap burst. 0 means fixed. 1 means increment. 1 means a wrap, like that. Next, cache. Cache behavior is mostly it is we have two types of interconnects. I already shown you in a SOC. We have cache coherent interconnect and not coherent interconnect and non-coherent interconnect, right? Cache related will come under coherent because where we have the cache in the processor. In processor only we have the cache, those will come under coherent. And all IOD functional blocks will come under non-coherent. That's why here cache signal is there. Mostly for memories we use that signal or else not required. Next, to protect signal. You already know protect signal. In APV also we have just protection level, whether it is a privileged or user or secure, non-secure instruction or data, same. Next, ID. ID in the sense for every write transaction, this is related to write, right? So if it is a read, for every read there will be ID. For if it is a write, there will be ID for the write transaction. So useful for the master transactions or masters. Okay, just ID for each transaction. Next, length. Length in the sense burst length. So number of data transfers in one burst, like a 0 to 15 or 16 transfers, like that burst length. Okay. Next to lock. Lock in the sense like master lock. It's just exclusive access, mostly not required. If any specification related is there, then only it is useful. And next, QoS, quality of service, that is also optional. Okay. Next, region. Region means memory region attribute, just memory in which region it is working. It's also optional. User also optional, just user defined signal. If anything is needed extra, that is reserved for the signal, user defined signal. Okay. So these are the different write address channel signals in AXI protocol. Clear, everyone? Any doubts?
In AW length and AW lock, there are two kinds, like 3 down to 0 and 7 down to 0. I mean, how it depends in
Uh,
AW lock.
Actually, here one is related to the opcode and one is related to the two types will be there. If you see in RISC processor, um, okay, leave it about RISC processor. Okay, see, suppose these 8 down to 0, if there are some operations like add, sub, multiplication, and logic or so these comes under any one operation. In that operation, we have again sub classifications. Like that here also length. Whenever we take the burst in a fixed means a single transfer. Increment means the 7 down to 0 will indicate the increment. But in increment we have increment 4, increment 8, increment 16. So that subdivisions will be decided by this W length. So we have two types. We can use either 4 down to 0 or 7 down to 0. Okay. Any other doubts? So that is about the write address. Next, write data. In write data also same valid signal, same ready signal, just wait state. And last means it indicates the last beat in a burst, last transfer. Just it indicates the last transfer. Last beat is nothing but transfer. Okay. Next, write data. Write data, it depends because in a XI protocol we have till 128-bit data. So 32-bit data or 64-bit data or 128-bit data, it depends. Even strobe also either 4-bit strobe or 8-bit or 16-bit. Strobe is nothing but just valid or not. It just check that. Okay, suppose if write strobe is equal to 1111, 4-bit means all bytes are valid in that 32-bit bus. In 32-bit, how many bus will be there? How many bytes will be there? 16. So total 5 bytes will be there, right? So if all are 1, it just indicate the strobe as a all 1 if all the signals are valid. Okay, all bytes. Next, ID. ID means you already know, just indicate the some ID number to the each transaction. Next, one signal is reserved for the user X. Any just if anything is important like needed, then user signal will be used. Okay. Like that, write response B channel, it will indicate with the B valid, B ready, B response, B ID, B user. Okay, same. Next, read side. Read address, read address channel. So your valid, your ready, you already know. Your address, your size, your burst type, and cache properties are implemented here. AR protect, AR ID, AR length, AR log, QoS region user. Same as a write. Okay. And coming to read data, valid, ready, last, data. Data also same here, either 32-bit data or 64 or 128-bit, and ID user. Okay. So these are the main signals in AXI protocol. Clear, everyone? Any doubts still here? So you need to understand here, valid and ready signals are there. So from handshake mechanism, okay, data or control is transferred only when both are high. When both ready and valid are high. If you see here, when valid is high, ready is high, then only both address and data will be transferred. Okay. Like that, we have AWID. If you see here, AWID in right side, AWID, ARID, BID, RID. These are used to match responses with the request in out of order scenarios. I will explain you out of order transaction. And so that is what main. So now you will understand what is the difference between transfer and transaction. Okay. So as I told, transfer means it's a single beat. Okay. Each time here there is a valid signal and ready signal. So each time valid and ready handshake happens on any channel, on any channel, uh, valid and ready handshake happens and at one transfer occur. Okay, every transfer. So mostly transfers when it will happen in AXI, we have 5 channels. Okay, transfers are divided into address transfer, data transfer, and response transfer. Okay, in AHP protocol, we have 2 clock cycles, right? One is a address, one is a data. Address phase, data phase. Address phase is a single clock cycle, data phase is a multiple clock cycle. Okay, like that in APB protocol we have phases, same setup phase, access phase, ideal setup access phase, 3 phases are there. Okay, in AHP address phase, data phase. Okay, in the same way in AXI we have like this address channel, right address channel, right channel, response channel for write. For read, a read address channel, read data channel. Okay, so like that here transfer means it have different transfers like address transfer, data transfer, response transfer, like that. Okay, so for example, suppose there is a 4-beat burst write, 4-beat burst write. Okay, 4-beat burst write means what? One will be the address write transfer. Next 4 beats will be the write transfer, and one transfer maybe response, B response channel. Okay, so total 6 transfers will be there, suppose for 4-bit. Okay, in the same way here transaction means like complete complete operation. Okay, like it consists of multiple transfers. Okay, so mainly in AXI transactions are burst, same in AHB also same, but those are aligned. In AXI these are non-aligned. Okay, so the transfers are burst based. So which means one transaction can include multiple number of beats, nothing but multiple number of transfers. Okay, so as I told before, one transaction is nothing but like a write transaction, nothing but where we do the write address plus write data. Okay, read transaction means read address plus read data, same way. Okay, so did you got the difference? What is mean by write? What is mean by transfer and transaction now?
Yes.
Hmm? Any doubts?
Those.
Hello.
Yeah, no doubts.
No doubts.
Okay. So next concept is here waveforms are there. So if you observe here the waveforms comparatively with the AHP protocol, these are the channel transfer examples. Okay, there is a clock and information like data and address valid. Whenever valid is high, read is high, then only we can do the write operation or read operation. Okay, so here next valid is low and ready is high. Even ready is high but valid is not high. We cannot read and write the data. So here if you observe, whenever both valid is high, ready is high, then only we can do. First case is it is indicating that even valid is high. If ready is not high, we can't do the operation. Here in second case, it is indicating that even ready is high, but valid is not high, we can't do the operation. In third case, it is indicating that whenever valid is high and ready is high, then only we can do the write operation or read operation. Okay. So based on that, remaining transactions we need to do here. Okay. So first write transaction. Write transaction single data item. So if you see here, before in AXI or AHP, how we do the transaction? First clock is high, reset is high. If it is a APB protocol, whenever setup phase, access phase will be there. In setup phase, whenever select signal is high, and in access phase, whenever select and enable signal both are high, we can do the write operation, read operation uh, based on the that what signal, ready signal. If ready signal is high, then only we can do the operation, or else it goes to the wait state. So that is APB protocol. AHP protocol, what we have seen, there will be bus transfers, increment, wrap, we need to understand, and aligned, we need to make the addresses according to the based on increment and wrap. So in address phase, we transfer the address, and in data phase, we get the data. So that is what in AHP protocol we have seen. Everything is signal wise only. Okay. But in AXI, we have channels. Okay, see here. AW channel. First one is a AW channel. So AW address, passing the address. Okay. And whenever AW valid is high and AW ready is high, then only we can initiate the transfer. Okay. So when both are high, just going to the right channel, right data channel. So now the data is coming. Again here also, whenever valid is high, ready is high, the data is going to transfer. The data is going to transfer. In the transfers, here there is a burst transaction and multiple transfers will be there. Here just W last is a signal which indicating the last transfer or last beat. Okay, so that is what last W last here. So here data, here this data is a last transfer. Okay, that's why here last is high. Okay, in the same way, B response. B response, it means just in APP protocol we have slave error. Okay, in AHP protocol also we have error signal. In AHP what signals we have? B response signals is there, right? B error indication and response indication. I have shown already that time. Ready out. If ready out is a 0 and response is 0, entire error will be getting. If response is high and ready out is a 0, partially error. I have shown that table already. Okay. So that is how we get the AHP response. Okay. But in AXI, we have a channel separately to get the response also. Everything will be done parallelly. Okay. So B channel, response channel, we have response signal. So we got the OK response. In response also we have two types, OK response, error response. Okay. So here we got the OK response. So if whenever we got OK response, the valid is high and ready is must be high. Okay, like that, multiple data items. So we are transferring multiple data beats in one transaction. So if you see here, Whenever validity is high, ready is high, then only doing the write transaction. If validity is 0 or even ready is 0, it is not acceptable. The data is not acceptable. And for last transfer, it just indicating W last here. Okay, like that. Okay, response same. Okay, same read transaction, read address, read valid, and read ready, and same multiple transactions, read data, valid, ready, last, response. Okay, response. Okay, so read multiple transactions here. So this is how the waveforms will work in a AXI protocol. Okay. Clear everyone
Hello,
till here? Yeah,
hello.
tell.
I have one doubt. Okay, in write transaction, okay, we have a separate write response channel, right?
Huh.
In read transaction, the separate read response channel is not there.
Okay.
Why it
Read,
is?
for read side, we don't have the response. Only for write side, we have the response. Because write data only we will get, right? Whenever the write data is properly transferred to the read or read, then we get the response. Okay.
Okay, fine.
Read side, we don't need of any response.
Okay.
So only 5 channels. So here we have completed the introduction part and also completed the signal list, and also Snoop signals are there, but these are not required. But once the entire specification, just go through that. And also we have completed this channel handshake mechanism, write read channels, and all these channels, and these transactions are completed. And we need to discuss on another main important concepts in AXI protocol is multiple outstanding transactions. Okay. So what it means, multiple outstanding transactions means just AXI support the multiple transfers before previous one is completed. Suppose if you see here, uh, this is entire transaction, one transaction. Okay, one read transaction. In this one read transactions, how many transfers are there here? Data 1, data 2, data 3, data 4, like the 4 5 transfers will be there. Okay, so that entire thing we call as a one transaction. Like that, we can send multiple number of 10 number of hundreds of transactions at a time. Okay, but in APB, AHP, we don't have that concept. Once we complete one transaction, then only second transaction will be started. Okay, but in AXA, we have multiple outstanding transactions where multiple transactions can be sent before previous one is completed. Okay, but how those transactions we will understand, we will identify, means by using each transaction. As I already told, each transaction is tagged with an ID name, ID signal is there here, right? ID signal. Okay, so each transaction is tagged with an ID, AWID or ARID. Okay, so that the responses can be matched with that correctly based on the right side ID and the read side ID. Okay, so that mostly it is used for pipelining operations, and automatically it increase the latency and also throughput. Okay, so suppose example, if we have an example like there is a write transaction. Wait. So till here, any doubts? Everyone understood the channels and how the waveforms are working? Everything understood?
Yes,
Okay.
understood.
Suppose there is a write transaction. A is one write transaction. Okay. And B is another transaction. Okay. Two transactions are there. So A transaction have the ID number as a 1 and B transaction have the ID number as a 2. Like that C transaction will have the ID number as a 3. Okay. In APB or AHB protocol, we cannot send all these three transactions at a time. But in AXA, we can send all these three transactions at a time. That's what we call as a pipeline. Okay. So here, suppose before transaction A, before completing the transaction A, B is in progress. Suppose. Okay, B is in progress. In that time, what happens? The slave process it as a out of order transaction here. Process it in a order. So first it will be getting in a order and next it will be getting. So it process the order. Okay. Did you got my point? The slave just put them in order or out of order. If it is, suppose here it is not started its transaction, so it will be out of order. That means it is not in the particular transaction. After completing, maybe once whenever it comes its time, it will okay. So like that, it must be use the ID to indicate which response belongs to which transaction. Okay, so that is what main advantage is. It improve the performance and it utilize the bus in a best way, for like high speed transactions. Okay, so in that case, what happens? Master continue Master will continue sending new requests without waiting for each response. Master will initiate the number of transactions continuously. Okay, so that's how the AXI protocol is represented as a high speed protocol. Okay, suppose processor side, I already explained why we use the AXI at a processor. Suppose processor having multiple number of instructions. Okay, so nearly suppose in SOC here is a processor and processor is communicating with some um, keyboard. Okay, or some there is a Wi-Fi module and there is a GSM module or some Bluetooth module or there. Okay, so at this point of time, processor is running 500 instructions. Processor is running 500 instructions. Okay, so do it run all 500 instructions only for this particular block, only for this particular Wi-Fi block, or any peripheral? If you put here, suppose there is a timer, will it send all 500 instructions to this timer? No. Or do it send all these 500 instructions to this Bluetooth module? No. Okay, so these 500 instructions are splitted to some memory controllers and some graphic processor controllers, or in some common shared IPs. To different number of IPs it will be communicating. Okay, so maybe 5 instructions are getting to this Wi-Fi module and 10 instructions are getting to this Bluetooth module, and some 50 instructions are getting to this memory unit, and some 50 instructions are getting to this graphic processor. Okay, so if you understand clearly, here 500 instructions are running at a time. Okay, as we seen now, in AXI protocol, we are able to run all the transactions at a time. Transactions is nothing but instructions only, right? Those will be converted in terms of transaction. Write data, read data, it will be converted. Okay, so that's why to maintain these 500 instructions, or just to work with these 500 instructions, this type of protocol is required here. And that too, all transactions are done parallelly means what? whatever the number of instructions it need to send to all blocks, it will be done parallelly. All transactions are done parallelly. No need to wait one after another. Okay. Coming to this Wi-Fi module, it just use the APB protocol. Okay. APB protocol means what? One-to-one transaction. It accept only one-to-one transaction, not all transactions at a time. Okay. Okay, no problem. One-to-one also no problem. Why? Because it just accept only, it just required only 5 instructions, right? Only 5 instructions are getting. According to that, one by one, it will be doing its task. Okay, one by one instructions will get, and according to that, it will react. Okay. So that is what the main, why do we say AXI is a high speed means, and why do we use at processor side means, that is what the reason. Did you got the clarity, everyone?
It's a bit confusing. Means like processor is sending all at a time parallelly to every block, right? But in AXI, it is taking one by one. So how is it happening?
How it is happening in the sense, um, like one instruction, one transfer is getting. One transfer means first write data is getting. Suppose
Yeah.
here the processor want to write the data into this particular register as a 25. So in first transfer, it's just writing the data to that particular address. Once this write operation is completed, again second transfer will be initiated, second transaction. Once second transaction is completed, again third transaction, one by one.
Okay, but the CPU is sending all at a time.
Okay. Middle we have a bridge, right? Bridge will
Okay.
convert that high speed to low speed. Here we have channels. In channels we have those many signals, but how those many signals are converting into APB? Because of bridge.
Okay.
Okay.
So, ma'am, it is
So
receiving one by one. Then how? So it is called as a high speed. So, but still it's taking one
that's
by
why we
one.
are calling APB as a low speed.
APB, yeah. Okay,
APB
okay,
is a low
okay,
speed. Here we are
okay.
using AXI. Here we are using APB.
Okay,
AXI is a
okay.
high
This
speed.
is
That's why here I told all are doing at same time. All transactions can be done at a time. All transactions are pipeline. But APB is not pipeline, and also APB doesn't have the multiple order transaction. Because of that, it is transferring only one by one transaction. That's why we are calling it as a low speed protocol.
yeah, yeah. Got it. I thought this is a AXI. Okay.
Okay, so that is what out of order transaction concept. Okay, so it just mean that responses can come back in a different order based on the request. So one by one based on the ID, the transfers will be done. Okay, so clear everyone? Any doubts still here?
Yes, ma'am.
What doubts? So you just concentrate on the specification, almost completed. Maybe in the next session, now we will discuss these any other concepts in XI. Till signal list is completed and this transactions also completed, and these write, read, stroke, burst, attribute, transfer address. If you observe here, it will be look like these only. But if you go to conceptual wise, if you read, you will understand very easily. Okay, just start with the 5. We will in the next session we will start with the 5, but these are not required. But we will have just overview of all. Okay, then we will move to VIP development of AXI. Okay, tomorrow session Tomorrow we will discuss AHB to APB bridge. Any other doubts?
Prasanti, like in these protocols, I mean, just that interview questions you have sent and the system verilog UVM, that only is a thing or something else like we can practice in the protocols.
In protocols, what will be there to practice? You need to understand the specification. You need to write different test cases. You need to write the test plans. So you need to develop the SVUVM program from scratch. First thing, you need to understand the specification, every point to point. If you want to learn very depth, very depth is not required. But if you are interested and if you want to learn, just read the specification, entire specification, every line to line. Then try to develop some design or try to develop some VIP. That is how we get actual practice. Protocol is just understanding the specification. That's it. In interview point of view, they will mostly concentrate on how you develop some test case or test bench, or how what specification you did and how we design the driver, because AIP VIP means all we can't do. One person can't develop entire VIP. So you should be contribute for just a driver block or for scoreboard block or for any monitor or sequence item. So you need to be perfect in any one of the block, right side or read side, whatever. Okay, so that is what protocol mostly. Still, any what will be there from protocol?
Yeah,
Specifically,
okay.
we can put in the resume like you developed the you tested, written the test case for valid signal, uh, ready signal. Specifically, you written the logic for scoreboard. Whenever logic is not logic, whenever valid is high, ready is high, then do the right operation. Like these kind of things you can put in the resume. Like we have the waveforms, right? From that only we will develop entire VIP. We do the verification from that waveforms only. So if you are interested, you can particularly put these kind of things in resume, particularly if you developed any logic in this. Actually, here I am telling every point to point all, even the verification also. But real time in resume, what you need to put means what you have contributed to that particular protocol, what you have developed your own, which signal you have verified properly. Suppose burst transfers are there means in AHB, I have explained entire RTL for a incremental wrap. Okay, from that you can put like you design the RTL for like increment wrap, or else you have written the simple scoreboard logic to check the bus transfers, to verify the bus transfers, like that. You can just recreate the resume, and according to that, just prepare and attend for the interview. Okay, that is best thing to put in resume. If you put like this, it will be good. Okay, not just learning the specification of AXI, just developing the web. Yeah, that just common thing. Okay, any other doubts? Okay, tomorrow we have a session, AHP to APB bridge. Okay, Tuesday to Sunday I will assign another mentor. Okay, Saturday there is a session again for AXI. Okay, for XI.
Ma'am,
Wednesday, there is a, please let me wait.
yeah.
Wednesday, we have a session, Wednesday, on static timing analysis. Okay, PD engineer is going to take that. Mostly, I think she will be available on Wednesday. I will confirm with her once. Okay, so STA topics will be there on Wednesday. Okay, tomorrow, AHP to APB. So, everyone try to attend. Okay, yeah, tell now.
Tuesday, there is a no any session. There will be no any session, right?
I will see for Tuesday.
And ma'am, please take you take the UVM session now because you teach us with very so much of clarity.
Actually, UVM mentor is very good. Actually, he is not Maheshwar. Another mentor is there, but
No,
okay,
I'm not.
okay,
Mahesar is also good, but on describing the code, we got not so clarity.
okay,
Uh,
fine, no problem. Then
please,
Tuesday we don't have the session. Thursday we'll have a session. I will try because this whole week I will be not available. I told right,
the
but I will
test
try
bench,
to take.
the test bench writing part he described well, but each topic code we got so many confusion. That's why. Please, you take at least the UVM.
Okay, fine. That's why I shared the recorded sessions also for UVM.
Yeah,
If
yeah,
you
ma'am.
want,
It
if
will take.
anyone looking
Yeah.
to complete fast, anyway, we will discuss live, not a problem. But if anyone looking to complete fast, you can just refer those all sessions one by one. Okay. Okay, then. Thank you all. Bye.
Please share that system data of session test
Uh,
bench.
I will share now only. Which session? This only, right?
This may be like on for Monday, no? That one.
Fifth, fifth date.
Fifth, then that this one only.
Okay. Okay.
I am also not sure. You share, I'll check.
I didn't share it. But how you won't confuse, huh? Like these sessions and those sessions.
Confused means?
I already shared the UVM sessions, right?
No, like this is not UPM. This is actually like system data test bench you like described. That part.
Okay. Okay. I will share.
So, ma'am,
Yeah, tell.
in today's market scenario, BTech is sufficient
What?
or they need master guys.
What?
Trend, ma'am, trend BTech students are sufficient or they need master student.
For what?
Companies, ma'am, in today's market trend, companies need
Which year passed out you are?
I'm current bench for 2025.
25. Okay. Yeah. Like 25 means mostly you will get the internships from product based company. Product based companies, they won't hire directly as a engineers. Okay. You need to try for internships. But service based companies, we can go as engineers. Um, Mostly if you apply for 10 service based companies, we will get two or just two max. Hmm? Share me your resume. I will check. Okay. Okay then. Thank you all. Bye. Ashwini, do you have any doubts?
No, Prashanti.